gray code. Or whatever, any number of numbers may be there, I can reprint. See, the thing is, when the basic properties of gray code are, first important property is it is reflexive. Gray code system is reflexive system, and which is Unicode system, and it is following a property called cyclic property. And then I cannot call it as sequential system because you are not going to get the values. I can call it as unweighted coded system. Unweighted code, right? Unweighted or non-weighted coded system, because it is comes under non-weighted only, because you cannot able to assign the values to the each and every particular location, right? Guys, if you observe, if I am going to have one number, one digit only, what is the, if I am going to place this number in the mirror, opposite to the mirror, what is the value of this one? 0 only. If I am going to have only one bit, 1, mirror number is 1 also, 1 only. Am I right or not? But if you take two numbers in a system log 0 and 1, if I take 0, whose mirror is 1, for basic one system, right? You have to think. For example, if I take 2 bits, like 0, and let me take as, I am trying to take it as a mirror. Try to think, if I am going to have 0 1, what is the mirror of this 0 1? Can I call 1 0? Yes, right? So I can call this as a mirror, so try to put two numbers 0 like this. So don't think about the first portion, just compare only the second level of bits. This is what I can call it as mirror, so I can call it as reflexive. Try to extend this one to 3-bit system. What is going to happen? If this is mirror, here what you are going to get? 1 0, here you are going to get 1 1, here you are going to get 0 1, 0 0. Is it okay? Now try to add the whole like above all are zeros and below all are ones, right? Is it a mirroring or not? Yes, right? So try to think. I'm going to write the same thing here. See, I have written something like this: 0 0 0 1, 0 0 0 1 is, so for this 1 0, what is the mirror? 1 0. I put just 1 1 here, right? For this entire thing, I made one mirror: 1 0 1 1 0 1 0 1. Sorry, 0 0 0 0. Right? Now try to add number of zeros and here number of ones. So it is simply look like a mirror. So I can call it as it is satisfying the property called reflexive property. If you want to extend, what you can do? You can simply make this as a mirror and add above zeros, add bottom ones with reflexive property. Okay, fine. See how you are getting this one. So you should not, like, for example, in the question, if they give like what is the gray code of 456, you cannot able to write like this values, right? So try to think, what is the actual value of 110? So I mean 4 in normal binary system, what is the value? 100. Okay, fine. So now try to think how I am getting the 110 means I am going to write the 1 as it is, and I am trying to perform XOR operation over the earlier number and the present number. 1 XOR with 0 is what? 1. XOR operation. When both are different, result is 1. When both are same, result is 0. 1. What about the next number? 0 XOR with 0. 0. Are you going to get the number or not? Right? Try to take out the value of 2. 2 value is what? 0, 1, 0. Try to perform XOR operation. How we are going to do this? 0 should be 0 as it is, and 0 should be XOR with 1, that is 1. 1 XOR with 0, 1. 0 double 1. Is 0 double 1 you got or not? This is the way you can able to convert binary to gray code. Meaning that if you know binary code, you can simply convert it into gray code by making use of XOR operation, right? Meaning that if you are going to have multiple numbers A1, A2, A3 and A4, or you can just simply make opposite A4, A3, A2 and A1. If you want to get the gray code, first simply add A4 as it is. A4 as it is. A3 how we are going to get? Sorry, B3. Next number how we are going to get? A4 XOR with A3. Next number is A3 XOR with A2. Next number is A2 XOR with A1, right? In simple terms, if you would like to say, if you would like to find out the next number Bn, what you are trying to do? You are trying to perform An plus 1 XOR with An. Is this equation is correct? Yes or no? Right? This is where it will be helpful for you. If I am trying to find out like B3, try to substitute. If I am trying to find out the B3, how we are going to get to B3? A4 plus A3. So try to substitute. Here n means 3 plus 1. That is A4 plus A4 XOR with A3. Is it okay? Yes. So this way you can able to do. Okay. Fine. Similarly, if I am going to have an XOR number, if I am going to have like gray code, can we able to get binary code? We can do that. Try to observe. If I want to get the number, I am going to simply right. So you can simply get the value of the most significant bit 1 as it is, and try to perform XOR operation of the previous result with the current bit. What is 1 XOR with 1? 0. The result of previous bit should be XOR with the current bit. 0 XOR with 0 is 0, right? 100. Are you going to get 100 or not? So this is the procedure you have to follow. See, observe 011. So you have to write the as usual procedure 0. You have to perform XOR with 1. 0 XOR with 1 is 1. 1 XOR with 1, 0. So 0 1 0 you got. Right? This is the procedure you have to follow while converting gray code to binary code. Right? Indirectly I am trying to say that if I would like to find out the A1, what you are trying to do? I am trying to simply perform XOR operation of all the things. An minus 1, An minus 2 and so on A2. If you want to find out the A1 value, I am simply finding the XOR operation of all the things. Okay now, this way. If you want to find out the value of A2, what you have to do? I need to perform the XOR operation of An to A3. Is it correct? Is it correct or not? Try to check. See, if you want to know the value of this 0, what I am trying to do? I am trying to perform XOR operation of this value with this value and this value, right? What is this 0? Earlier value. What is this value? Actual existing value. Indirectly I am trying to say that I am trying to perform the XOR operation of all the values. Okay. See why I am trying to do all the things means, so this analysis is required when you are trying to construct circuits. Like for example, if you analyze something like this, assume this is a circuit board. Circuit board. For this circuit board, I have given 4 inputs. What are those inputs? For example, let me take A1, A2, and A3 are the inputs I have given, right? So for this, what is my so like assume that this is a kind of circuit which is meant for to convert binary code to gray code. What is A3? A3 should be directly written or not? A3 should be directly written. So A3 will be directly connected to the output B3. B3. How we are going to get B2? B2 you are going to get XOR operation of A3 and A2, right? So I am going to take the input of A2 and input of A3. You can, so there is a symbol called XOR operation symbol which is going to produce B2. Produce B2, right? How we are going to get B1 here? XOR operation of A1 and A2. So like this you need to draw the circuits in the future. So that is where you are required this kind of analyzation, right? See, now try to observe, try to analyze. If I am going to give the input like I am trying to take some number 111, 111. If I am going to give 1 here, if I am going to give 1 here, that 1 will be occurred here and 1 also will be occurred here. A2 will be here. What is XOR operation of 1 and 1? 0. B1 output is 0. What is the here 1? Here also 1. What is 1 XOR with 1? 0. What is A3? Is there any processing done here? No, directly copying, right? This is 1. So meaning that if I am trying to perform binary code 111, what is respective gray code? 1 0 0. Are we going to get 1 0 0 or not? Yes. So like this, the system should have to capable system have to solve, right? As a human being, we are going to work on paper, but for the system, it can able to do it with the help of circuits, right? This is why you need to learn all the things. Okay, fine. Here I said like it is reflexive, okay, and why I am calling it as Unicode means if you observe any two systems which are immediate to this one, how many bits are changing? Only one bit is changing, that is only 0 and 1. If you observe these two, how many bits are changing? Only 1. If you observe these two, how many bits are changing? Only 1. If you observe these two, how many bits are changing? Only 1. This is what Unicode system, meaning that at any point of time if you take two adjacent numbers, only one bit is going to be changed. Only one bit is going to change. That is what I can call it as Unicode system. Even if you take the corner numbers 7 and 0, only one number is going to be changed. 100, only 1, only 000, right? This is why I am calling it as cyclic code also. Cyclic code, right? Meaning that if I am going to give the number, if I take the numbers from 0 to 7, if I are going to generate the processing, always it is going to get the numbers from 0 to 7. Simply nothing but modulus 7. What is the meaning of modulus 8? Modulus 8, modulus 7. Modulus 8, what are the range of values we are going to get if you give n value as numerator? 0 to 7, right? So that is the only. From 0 to 7 you are going to get always the values, right? Cyclic code. Next, this one is unweighted code which you know. Okay.